Hello, everyone. You may have heard about feature teams and component teams. Really familiar terms in the agile world when we are referring to different constructs for teams. And this is normally referred to as team topologies. So let's see what they are. We'll sort of dive deeper into what feature teams and component teams are, and what is sort of a more advanced way to look at team topologies and classify them into different types of teams. So the way I want to approach this is we have the feature teams and component teams, and most recently in the scaled agile community, we have a slightly different terminology that is introduced, and I'll tell you what the source of that new terminology is. Feature teams are normally referred to as stream-aligned teams. And then we have the component teams, which are basically slightly different in the new terminology and broken down into complicated subsystem team, platform team, and enabling team. Now we'll dive deeper into what each of these teams are with real examples. But before we go there, the new terminology is from a book called Team Topologies from Skelton and Pace, which is, as I said, what the Scaled Agile SAFe 6.0 refers to when discussing team topology. Now, let's use an example, a made-up example, that is that I put together to explain how we can approach a certain program of work to implement different team topologies, different team constructs, right? How the whole program of work can be organized. And I have to say this can be scaled to the whole organization, portfolio level, solution level, program level, you name it. But in this case, it's pretty simple. We have a program of work, right? That is defined to deliver a solution that integrates several data sources across inventory management, sales, and production, and optimize the production plan by factoring the stock available, like stock quantities that are available to the production line, machine and human resource capacity, among other factors. It also allows management to get insights into production line performance. So it's a manufacturing context, fairly complex solution context that I deep dive into. And we are basically tasked to look at the team topology, the team construct, and see how we can basically form those teams. And we look at different options around that and the pros and cons of each option. So let's go. So the solution context is that we have some external data sources and we have data integration. This is supposed to sort of consolidate all those data sources, stand up perhaps data pipelines, do ETL, do data analysis and data science in certain cases. That's one component of this solution. Then we have a complex AI/machine learning model that does a lot of computing in terms of, what are my stocks that are available, what machinery I have available, what inventory levels I have available, what are the jobs that I have to pick up, and it sort of consolidates all of these based on complex ML models and optimizes basically the assignment of those jobs into the individual resources, or based on the individual resources, sort of puts together a production plan for the production line to be to pick up and sort of work through their jobs one by one. But for the sake of our conversation, the details of this model is not important. What's important is the complex model, and it plays a significant role in the overall solution landscape. Then obviously we have the user interface for the system under design. We have to stand up a number of new user interfaces to basically serve our end user community. We have a legacy finance system that needs to be integrated into this ecosystem. And obviously any finance transactions back and forth need to be integrated into that system. Then we have application integration. So various applications are involved here. We don't want to, again, go into details. Several applications. These applications need to be integrated. And then most of our solution is cloud-based. Whatever resources we have, from databases to, say, for example, S3 buckets, whatever. Let's say they are all hosted on AWS. It could be Azure or whatever. So a lot of these services at the end of the day are cloud-based. Now, let's look at the resources. In the external data sources side of things, we have 8 data integration developers and data scientists. So they reside basically in that data integration space. We have 5 resources specializing in that AI ML model. We have 12 UI designers and developers working alongside each other for the UI side of things. We have 4 cloud engineers. We have 8 API/microservice developers. And then we have 3 resources specializing in that finance system. So this is pretty much the resources available to the program. And again, going back to the original question, we are tasked to find the best, or at least recommend or explore some of the topologies that are possible here. So let's look at the first possible topology, and that is normally referred to as feature teams, or in the most recent vocabulary, referred to it as stream-aligned teams. And the key aspect of stream-aligned or feature teams is that we want them to be as cross-functional as possible, right? We want them to have basically all the skill sets that they need. That's one thing, and the other thing is we want them to be working with the established group of customers directly. Now, how you pick those customers, the sky is the limit, right? You can pick a particular journey or like a number of journeys and give it to one team. You can pick a particular persona. You can do it based on the organizational structure or value streams. There are lots of options there. In this particular example, we have decided to sort of establish 3 feature teams. And these, so going back to our original problem, in that organization, manufacturing again, to remind everyone, we have production planning and control as one discipline, basically, or one division in that organization. And we have maintenance, inventory, and asset management, briefly referred to as MIA, as another division. And then we have reporting and governance as the 3rd division. And pretty much in this program of work, we need to deliver functionalities in each of these areas. So there are certain functionalities that are related to PPC, production planning and control. There are certain functionalities that are related to maintenance, inventory, and asset management, the MIA team. And there are certain functionalities that are related to reporting and governance. So the first stream of work, or the first team, would basically work directly with the PPC customers with the same token, MIA customers, and RG customers. Now, let's look at some of the pros and cons of going with this team structure. So earlier we've seen that in each of these teams, we had all the skills that we needed. We had UI developers, specialists in the finance system, cloud engineers, API developers, data integration developers, data scientists, etc., etc. What's going to happen when you do that is you realize in one team you have all the skills that you need and you're working directly with a customer. So starting from the pros side of this table, um, they are very customer centric, right? They're directly working, for example, the production planning and control guys, that team are working directly with their PPC customers. They basically know their requirements inside out, and they are focused on that sort of group of end users. The second pro is that they're self-sufficient, right? The second advantage, they're self-sufficient. They don't need to rely on any other team to deliver outcomes to their customers, right? So they pretty much can pick up features and deliver those features end to end without the need to even raise a dependency in most of the time to another team. So the number of dependencies here will be minimized. It's not like you don't have any dependencies, but the number of dependencies from one team to another is going to be sort of minimized. And they're going to be very responsive, like they can embrace change. They have, again, all the skills that they need. So as soon as a change is required for whatever reason, they can quickly change direction because they don't need to rely on some other team to change with them, right? All the skills are sort of embedded into their team. On the con side or in disadvantages, they are isolated, right? So a lot of these resources, if we go back to the team structure, are highly skilled individuals, right, who specialize in a particular discipline. For example, one person might be a guru in the finance space, or we had, for example, data scientists who specialize in certain areas of that data science, or machine learning, like AI ML developers who specialize in that area. Especially in situations where you don't have many people, like for example, in this example, we only have 3 finance specialists or some 5 AI ML specialists. When you are standing up 3 feature teams, like each team is going to get 1 or 2 people, right, from that skill set. And therefore, those individuals are going to be very isolated from their community of practice. There are measures that you can take to connect them to a community of practice, but still, it won't be as good as being in the same team and bouncing the ideas off each other. So learning and improvement opportunities will not be the same as when they are working with people who specialize in the same area and come from the same mindset and background. And lack of this deep specialization is another area, because like these teams, they keep picking up features and deliver them. Their focus is on those features, and there could be a lot of variety in terms of the features they pick up. So they won't be able to specialize in a particular area of work. Now, let's introduce some variation to that original topology that we discussed. In this second topology, we introduced the concept of complex subsystem teams. Now, previously we mentioned that AI/ML model is a very complex one, and we have some 5 specialists in that area who maintain and extend the model, basically. Now, it may be to the benefit of both feature teams and those individuals who are specializing in this area for them to be to reside in the same team. So we establish a separate team, and it we normally refer to as complex subsystem team. It's basically this complex model, and that needs to be maintained and extended. And all those individuals will go to that team. So in this second topology, you do notice that there are no AI/ML individuals inside the stream-aligned teams. Instead, they belong to this isolated team that we refer to as AI/ML team. Now, this AI/ML team will basically service all these 3 stream-aligned teams: PPC team, MI team, and RG team, for whatever their need would be in terms of maintaining and extending that complex model. The stream-aligned teams, though, they're still working with their end users, so there's no change in that regard. Now, let's look at a more sort of distributed topology in this third variation. So we have platform and enabling teams as the third and fourth type of team that we could consider. Starting with the platform teams, we mentioned earlier that we have resources who specialize in data development and data science. We basically mentioned that one of the key components of our system are those data pipelines that we need to stand up to integrate data from several data sources into a single data source. So this platform team who specialize in this area or tasked with basically maintaining and extending these data pipelines and also catering to the needs of other teams when it comes to data science, for example, building forecast models, etc. Those data scientists come in. So this platform team, centralized platform team, again, will be servicing all our stream-aligned teams for whatever needs they would have. You would agree with me that in this context, those stream-aligned teams or feature teams would heavily rely on this team because the whole platform is built on the data that these guys need to integrate and make available to those UI designers, developers, and basically to those feature teams. The second platform team that we can establish is a team of API/microservice developers, right? As they specialize in creating those services and exposing them to other teams. They are a general purpose team who can build our integration platform, like whatever integration needs we have, they proactively go and build it. They build new APIs, they build microservices, and they look after the API/microservice deployment and make sure all those things are available to the teams that want to consume them. We still have our AI/ML team in this model. We're also introducing the cloud enabling team, who consists of a number of cloud engineers who would be supporting our our stream-aligned teams in moving their assets to the cloud and also maintain our cloud assets and resources. The reason we call them enabling team is because they are not only responsible for staying on top of our cloud resources, but they also educate the respective teams on moving and maintaining their assets into cloud. So what are the pros and cons of this structure? Again, I just referred to all these three styles, whether it's platform team, whether it's enabling team, or whether it's complex subsystem team. I think in the good old days, we used to refer to all of them as component teams. So the benefits of having such teams in our team topology is that they are very scalable, and you can going with the example of the API/microservice team that we discussed earlier, they could easily scale their operations up above this program of work. They could even go, organization-wide and support the whole organization with their API needs, with their service needs. They basically just need more resources and a lot of maintenance and support. They're going to be more consistent because they will be operating like a community of practice, and therefore their practices and design patterns and stuff are going to be more consistent. What they build is going to be a lot more reusable, again, because it's centralized versus decentralized, right? Because they have control over everything that is being built, they can find lots of opportunities to reuse those components. Whereas when their resources are in those feature teams, they don't have much control over what they do. They can put together standards and design practices and share it with them, but they have less control over whether those standards and practices are being followed, enforced, etc. So generally speaking, the level of reusability here is much higher. Proactiveness. In fact, not only this is one of the benefits of using this structure, it's one of, in my opinion, it's one of these requirements as well. For these teams to be successful, they need to be proactive. They need to always be ahead of the game when it comes to what feature teams need. So if feature teams expect certain bits of functionality to be picked up in the next program increment, for example, the API team must be working on the APIs that are required for those, perhaps in the current program increment, right? Or at least they have to be a few sprints ahead of the feature teams to be able to put together those APIs, deploy them to API gateways and stuff, and make them available to these teams to consume. And there's a learning and growth. Obviously, they can bounce ideas off each other. They will be connected to a community of practice, so there's more learning and growth opportunities for them. Now, what are some of the problems of adopting this style of or this topology? Complex priorities. So in this case, they would be getting requirements, basically dependencies from different feature teams, different stream-aligned teams, in certain situations from other component teams to stand up new services, new APIs, to make available new cloud services, for example, etc. So with all these dependencies and requirements coming their way, they have to constantly prioritize, and it's very difficult to prioritize one team's requirements over the other. So they need to be crystal clear in terms of like what sort of prioritization mechanism they're going to apply to decide, which of these requirements to work on first. Obviously, as I mentioned, they're going to get a lot of dependencies, and feature teams are going to have a lot of dependencies on these teams, and therefore managing those dependencies takes a lot of effort and requires a lot of rigor, because if you don't align those dependencies, the whole program of work is going to be in trouble. Dependency management is an ongoing hassle, and it's very difficult. So I can't highlight this enough, that in this structure, you're getting a lot of dependencies from your stream-aligned teams to other teams, and you gotta basically stay on top of all those dependencies for your plan to work. And finally, focus. Now, these teams may lose focus on the actual feature delivery and what is considered value to customers. Because they are isolated, they sort of lose sight of, what is valuable to the customers, what's important, what's not important. So they lose that focus. I hope you found this video useful. I tried to cover the concepts using examples instead of going through definitions and stuff. If you found this video useful, don't forget to subscribe and leave comments for me and give me feedback about the videos. Thank you so much.